responds. So it would potentially reduce the scope of projects that you're completing today, but then potentially politically, which Dale will talk about in just a minute, open up some other options for the district down the road for other projects. So in this case, the $38.5 million in current interest bonds would only cost about $6.3 million in interest. So your total payments of $44.8 million, a 1.17 rounded to 1.2 to 1 debt ratio. So this would obviously be the cheapest cost of financing for the district. However, it does not get you to the full $77 million. Any questions on where we are today before we move forward with the next slide?
Yeah, before we do, I want to underscore Mark's comment. Let's just go back to page 14 if we can. Because we tend to forget, we sit here and we look at the tax rates, and we think, okay, well that's a good tax rate, $100 or $85 or $60 or whatever it is. But sometimes we lose track of the fact that that tax rate involves both principal and interest. It's not just the principal that you're repaying, it's the principal and the interest. And that's why I find these two slides, 14 and 15, so interesting. On slide 14, which is the most efficient, allows the tax rate to go up to $100, but it's still the most efficient because your interest drops down to about a third of all the payments that the taxpayers will be making. So to put it another way, every tax dollar that is being charged in this alternative, about 30 cents of it is going to pay interest. In the alternative on page 15, we can talk about the timing problem in a second, but in the alternative on page 15, in that case, every tax dollar that's being paid, only about 15–20% is going to interest. Because that amount of interest is shrinking so much because you're not going out into the future using capital appreciation bonds and leveraging off those future payments. But then you ask yourself, yeah, but then what do we do about the remaining funds? When do we get our hands on those? And I think, to a certain extent, that's a policy issue. If you really need the money right now, and you really, really need it right now, okay, we've given you a few alternatives. But if you can wait a few years, a few things could happen. One, your assessed valuation might grow again, another couple, much higher than 3%, and you would be able to issue the remainder without having to issue capital appreciation bonds. Or even if you did, say in 2 years or 3 years, you say, you know what, we just can't wait. We need those, just that final shot now. It's going to be still cheaper because we've taken off a number of years as those calves would have to continue to ramp up. So pretty much any way you look at this, you're going to be, if you can do it, your taxpayers are going to be better off if you can keep yourself out of that high leverage part at the back end. That high leverage part is coming about because of those original caps, by the way, because they are pushing up to that $60 level under the 2010 authorization. The only downside, besides the fact that you wouldn't have the money, is someone could argue, well, what if interest rates rise? Wouldn't we be worse off then? And we looked at that. I didn't include it in this analysis, but we looked at it. Even if, on the entire $77 million, if interest rates were to rise a full 100 basis points, a full percentage points, and that's a pretty huge jump in the tax-exempt market, that would have an impact of a couple dollars on the tax rate. So it's not like suddenly you're going to have this huge increase. The real impact is the leveraging quality of these loans when you have to get them way out there and you're not paying them off. That's what's causing that huge amount of interest.
Let me ask a question. So when you say it goes up a couple of dollars, do you mean that it would go from $90 per taxpayer to $92 per taxpayer for 100,000?
Yes. Any other questions? right, let's talk about some opportunities going forward. Assuming you've solved your $77 million problem, you still have huge facility problems. So I wanted you to take a look at a couple different alternatives down the line, and then give you some political information. What this table shows on page 17 is more efficient than what happened in 2010. This assumes a $60 tax rate per $100,000 of assessed valuation growth of 3% over about a 30-year term. And using that, I mean, this is not high finance, this is simple arithmetic, right? Taking assessed valuation, $60 tax rate per $100,000 of assessed valuation, growing it at 3%, that produces, over that 30-year period, that would produce $1 billion in tax revenue. Not $1 billion in projects, $1 billion in tax revenue. So now is how do you most efficiently get that? If I could have you turn to page 18. This shows the most conventional method, and that's what it's called, conventional bonds. These are Prop 39 bonds, 3 series of bonds, sold 3 years apart, level debt service, by and large, and each bond would be made up of a fairly large principal component and then a fairly large interest component. That would produce about $500 million of projects that you would have, that $500 million over the next 9 to 12 years, because you're issuing them every 3 years. So about, remember we talked about that $1 billion, so about half of that would go to projects, $400 million to interest, and there's about $100 million that you just can't get to because it's so far out there in the future without issuing some sort of caps, and I didn't want to put those in the analysis. So that's one way to do it. A second way, and it works well in districts this size, you can see on page 19. And there's some downsides that I'll talk about as well. But this would be to issue these bonds on a more short-term basis. So parameters are the same. One voter authorization. You're going to the voters only once, not multiple times. In this case, you're looking for authorization of $520 million. You issue the first series of bonds, those are the ones in red. You issue the first series of bonds, but you pay them back in 5 years. Completely. Principal and interest are all paid back. And then, in the 6th year, you issue the second series of bonds. That would be about $120 million. Again, as a 5-year series of bonds, not a 30-year series of bonds, not a 25 years, 5 years. Only one voter authorization. It's up to the board to decide when they're going to issue and how much they're going to issue. But then in this case, in the 11th year, another 5 years, and 5-year bond. That would total about $521 million. Pretty close to the previous analysis. But if you look at page 20, you can see the impact on the taxpayer and on interest payments. So look at those two pie charts. In the first conventional, that $500 million is costing taxpayers another $400 million in interest over that 30-year period. With the 5-year bond, that $500 million, in this case $520 million, that interest drops down to about $43 million. Meaning there's $341 million of interest rate savings in this analysis. $341 million of interest rate savings. Now the downside of this, and by the way, most districts, I've made this presentation to taxpayer organizations around the state and a number of other business organizations, and they always say the same thing. Well, why doesn't everybody do this? I mean, if you look at the face of it, why doesn't everybody just do this? Well, you can see on the next slide why. On page 21. It means you're going to you would get less money sooner. So the blue represents the funds that would come in under that conventional analysis. You'd be getting about $200 million in the first 3 years, and then another $150 million, and that would go up to $500 million within 9 years. Whereas under that 5-year analysis, it's coming in a lot slower. Same amount of money, but it's coming in slower. And I put the average amount